In this video, we will discuss about spectrophotometer. Spectrophotometer. Spectrophotometer is a device which used to measure the amount of light absorbed by a sample at different wavelengths. It's a device used to measure the amount of light absorbed by a sample at different wavelengths. That is, it measures the amount of light that can pass through a sample. It measures the amount of light that can pass through a sample. This device consists of a light source, a sample holder, a diffraction grating or prism, and a detector to measure the amount of light absorbed at each wavelength. This device consists of a light source, a sample holder, a diffraction grating or prism, and a detector to measure the amount of light absorbed at each wavelength. It is a standard technique used in many chemistry laboratories. So, from the data collected, a computer can plot an absorbance spectrum for the sample. So, from the data collected by using a computer, we can plot the absorbance spectrum for the sample. Now, what is spectrophotometry? It is the action of measuring light absorbed by the sample using a spectrophotometer. That is, spectrophotometry is the action of taking a measurement using a spectrophotometer. So, the spectrophotometer is a tool which helps the scientists and researchers to study the properties of light and the interaction of the light with different materials. Spectrophotometer is a tool which helps the scientists and researchers to study the properties of light and the interaction of this light with the different materials. That is, by measuring the amount of light absorbed by a sample at different wavelengths, a spectrophotometer can provide valuable information about the composition and properties of the sample. That is, it used to measure the composition and property of a sample. The basic idea of spectrophotometry is that light passes through a sample and the intensity of the beam is compared before and after the sample. That is, light passes through a sample and the intensity of the beam is compared before and after the sample. So that different samples will absorb light differently and allow different amounts to pass through a different colors of light. That is, different samples will absorb different light and allow different amounts to pass through a different colors of light. Here, each molecule absorbs light. Depending on the molecule, it will absorb certain colors more than others. That is, depending on the molecule, it will absorb certain colors more than the others. This is a typical spectrophotometer instrument seen in labs. So, it is a powerful and versatile tool that is used in many different fields, including chemistry, biology, material science, etc. Now, let us discuss how does a spectrophotometer work. This is a simple diagram of an absorption spectrophotometer, which include a light source, a sample holder, and a detector. The light source produces photons. The light source produces photons that will pass through the sample. The light source produces photons that will pass through the sample. And the light source we used will depend on the wavelength of light needed. The light source we used depend on the wavelength of the light needed. Depending on the source, a collimator or prism select the correct wavelength. So, a collimator or prism is used to select the correct wavelength of light. The light interact with the sample. A cuvette is used as the sample holder. This is the cuvette This is used as the sample holder. This is a specialized piece of glassware with a very precise width and material. It's a specialized piece of glassware with a very precise width and material. And the material of the sample holder is very important. Path length of the cuvette. Path length of the cuvette is also important. The path length is the amount of sample the light passes through. The amount of sample the light passes through. So a cuvette that is 1 cm wide has a path length of 1 cm. So a cuvette with 1 cm wide has a path length of 1 cm. This we are used for the calculation, so that this is important. When we are selecting a cuvette, it should be 1 cm path length. After the light passes through the solution, it travels to the detector. After it is passed through the solution, it travels to the detector. Similar to the light source, the exact detector will depend on wavelength of light. Exact detector will depend on wavelength of light. Some of the most common detectors are photomultiplier tubes. Photomultiplier tubes. Photomultiplier tubes and photodiodes. The detector counts the number of photons reaching it. And this detector connects to a computer that plot the absorption spectra. The absorption spectrum is a plot of light intensity versus the wavelength of light. Absorption spectrum is a plot of light intensity versus wavelength. Light intensity versus wavelength. For example, this is the absorbance spectrum of rhodamine. So, the absorption or absorbance spectrum will be like this. This is the model of the cuvettes that we are using in the spectrophotometer. What are the common types of spectrophotometers? Spectrophotometers are generally classified based on the wavelength of light source. So there are two types of spectrophotometers, that are UV visible spectrophotometer and IR spectrophotometer. So this classification is mainly based on the wavelength of light source. The UV visible spectrophotometer is commonly referred as UV vis. UV vis. It measures the absorbance in ultraviolet and visible range. So the name is UV visible spectrophotometer. It measures the absorbance in ultraviolet and visible range. And generally it is 200 nanometer to 700 nanometer. 200 to 700 nanometer. And IR spectrophotometer, it measures the sample using IR light, infrared light, and the range is 700 to 15,000. 700 to 15,000 nanometer. Now coming to the calculations using spectrophotometry. The formula of transmission T equals LT by L0. Here T is the transmission, LT is the intensity after passing through the sample, light intensity after passing through the sample, and L0 is the light intensity before the sample. L0 is the light intensity before the sample and LT is the intensity of light after passing through the sample. The absorbance related to the transmission by the formula A equals minus log T. A equals minus log T. That is equals minus log LT by L0. Absorbance equals minus log T, that equals minus log LT by L0. Coming to the application of absorption spectra. Absorption spectra have a lot of different possible uses. First one is determining an unknown concentration. Absorption spectra can be used to determine the concentration of an unknown solution. Usually we are doing this by using absorption data of a series of solution of known concentration. Absorption data of series of solution of known concentration to create an absorbance curve. Then the unknown solution can be compared to this curve to determine the concentration. So by using a solution with a known absorbance, we can find out the concentration of an unknown substance. Concentration method used to determine the unknown concentration of the solution. One is identifying a material. Depending on the structure of the molecule, each pure material will have a unique absorption spectrum. So, an absorption spectrum helps to identify an unknown material. Each material have its own absorption spectrum. So, depending on the absorption spectrum, we can identify an unknown material. Next one is identifying functional groups present. Some functional group will have distinct spectral signatures. Identifying these in a spectrum, we can find out that that functional group is present in that sample. To identify whether the functional group is present or not, we can use the spectrophotometer. So these are all about the spectrophotometer, which used in common labs including chemistry, biochemistry, physics, clinical and material labs. Thank you.